Hello students. So this is module 5 we will be covering of 18MAT41. First topic which we will do is joint distributions. Tumba simple, very easy. Definitely recommended if you are in a hurry. So let us start. Now joint distribution ಅಂದ್ರೆ ಏನು? ಈಗ ಎರಡು ರ್ಯಾಂಡಮ್ ವೇರಿಯಬಲ್ ಅಂತ ನಿಮಗೆ ಗೊತ್ತಿದೆ, ಲಾಸ್ಟ್ ಮಾಡ್ಯೂಲ್ ಅಲ್ಲಿ ಆಗಿತ್ತು. ಸೊ ವಾಟ್ ಇಸ್ ರ್ಯಾಂಡಮ್ ವೇರಿಯಬಲ್ ಇದ್ರೆ ಅದ್ರ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ಅಂತ ಗೊತ್ತಿದೆ. ಸೊ ರ್ಯಾಂಡಮ್ ವೇರಿಯಬಲ್ ಇಸ್ ದೇರ್ p of x, the probability with which it takes those values, different values, is its distribution. Now you know one random variable and its probability distribution. Now next concept which we have to learn is there are two random variables x and y, and what is the probability that jointly they take a certain value. You will get to know once you see an example. So let us start with a quick example. So this is an example of a discrete, syllabus very discrete ಇದೆ, discrete joint distribution. See, p, you put x values x1 x2 x3 hinge, y values y1 y2 y3 hinge. p11 is probability that x takes value x1, y takes value y1. This is the setup. This is called a joint distribution function. So just so that you get a practice, let us look at this joint distribution function. Actual joint distribution function. Look at this one. Let us still look at this one. See, here x can take values 1, 3, 6. Y also can take values 1, 3, 6. So if you are asked probability that x takes the value 1 and y takes the value, y is equal to 6. What is the probability that x takes value 1 and y takes value 6? You will look at this table. X takes value 1, y takes value 6. So this is the cell. The answer is 1 by 18. By looking at the table, you can tell. So illi x can take values 1, 3, 6 and no other values. This is itself a probability distribution. X can take values 1 or 3 or 6. Similarly, y can take values 1 or 3 or 6 and no other value. So total number of various values is 3 into 3, 9 different values. What are the different values? X equal to 1, y equal to 1. This set. X equal to 1, y equal to 3. X equal to 1, y equal to 6. X equal to 3, y equal to 1. Atara 9 cells barutte. 9 possibilities are there. For each of these possibilities, there is a value. This is a distribution. So what property do you know of distribution? Yes, you told it correct. Total madadre 1 irlebeku. So if you can pause and check that e 9 values do total has to be 1. It is not even a distribution, probability distribution function. So our property irlebeku idde irutte, nam question paper alli adu irutte. So this is called a joint distribution. Jointly, what are the that p takes that x takes value 1 and y takes value 6. Jointly, e ಎರಡು value ಬರುತ್ತೆ ಅಂತ probability, we look it up in the cell and tell. So this is your joint distribution function. Now let us quickly start off with solving problems itself. So take this first example. Determine the marginal distribution, first part, and second, covariance between the discrete random variables x and y given that joint probability distribution is as below. So this is the joint probability distribution. If joint probability distribution nodi, x can take values 2, 5, 7. Y can take values 3, 4, 5. Just to see that you have understood joint probability distribution, what is the probability that x takes value 7 and y takes value 4? So you take x takes 7, y takes 4. This is the value 1 by 12, right? So total number of ways in which x and y can take values is 3 into 3, 9. So you have 9 cells. So this is the joint distribution function table they have given. First question nodi, find the marginal distribution anta. Okay. Now, e table nodidre, iga x takes value 2, y takes value 3 is 1 by 6. Iga, suppose I ask what is the probability that x takes value 2? Probability x takes value 2 ಅಂತ ಕೇಳಿದ್ರೆ ಯಾರು y ಬಗ್ಗೆ ಏನು ಹೇಳೋದೇ ಇಲ್ಲ ಅವರು ಜಸ್ಟ್ ವಾಟ್ ಇಸ್ ದ ಪ್ರಾಬಿಲಿಟಿ ಎಕ್ಸ್ ಟೇಕ್ಸ್ ವ್ಯಾಲ್ಯೂ 2 ಅಂತ ಕೇಳಿದ್ರೆ ಏನು ಉತ್ತರ ಕೊಡೋದು ಸೊ ನಾವು ಹೌ ಮೆನಿ ಆಫ್ ದೀಸ್ 9 outcomes ಇದೆ ವಾಟ್ ಇಸ್ ದ ಫಸ್ಟ್ ಔಟ್ಕಮ್ 2, 3 x is equal to 2, y is equal to 3. Next outcome is x equal to 2, y equal to 4. Next outcome x equal to 2, y equal to 5. Next outcome x equal to 5, y equal to 3. Fifth outcome x equal to 5, y equal to 4. Sixth outcome x equal to 5, y equal to 5. Seventh outcome x equal to 5, y equal to 3. Eighth is x equal to 7, y equal to 4. Ninth is x equal to 7, y equal to 5. Adbit ಇನ್ನೇನು ಇಲ್ಲ. So in these 9 possible outcomes, which of these 9 had x equal to 2? So this outcome, this one, and this one. Really, x equal to 2, y equal to 3, x equal to 2, y equal to 4, x equal to 2, y equal to 5. Really, x is equal to 2. So if someone asks what is the probability x equal to 2, don't bother y value, I don't care. What's the chance that x equal to 2? You will add these 3 probabilities. So 1 by 6 plus 1 by 6 plus 1 by 6, which is equal to 3 by 6, which is equal to 1 by 2. This is probability x equal to 2. So I can even write it here 1 by 2. These sum of these 3 I've written here 6 by 12, which is 1 by 2. Okay, next question, what is the probability that x is equal to 5? X equal to 5 do probability ಎಷ್ಟು ಅಂತ ಕೇಳಿದ್ರೆ ಏನ್ ಹೇಳ್ತೀರಾ? Which ಈ 9 ಕೇಸಲ್ಲಿ which cases had x equal to 5? So x equal to 5, y equal to 3, x equal to 5, y equal to 4, x equal to 5, y equal to 5. ಈ 3 ಕೇಸಲ್ಲಿ. So ಇದನ್ನ ಕೂಡಬೇಕು. We have to add this up. 1 by 12 plus 1 by 12 plus 1 by 12, which is 3 by 12. You have 3 by 12. Next, last question is probability x equal to 7 ಎಷ್ಟು? So similarly, this is this cell, this cell, this cell. You add it up, you get 3 by 2. So this is probability. Now x can take no other value other than x equal to 2, x equal to 5, x equal to 7. So x equal to 2, the probability 6 by 12. X equal to 5, the probability 3 by 12. X equal to 7, the probability 3 by 12. So ಇದನ್ನ ಬೇಕಾದ್ರೆ simplify ಮಾಡಿ decimal form ಅಲ್ಲಿ ಬರೆದ್ರೆ this is called the marginal distribution of x. Marginal ಅಂತ ಹೆಸರು ಯಾಕೆ ಬಂತು? Obvious reason. ಈ ಟೋಟಲ್ ಮಾಡಿ margins ಅಲ್ಲಿ ಟೋಟಲ್ ಮಾಡಿ ಬರುತ್ತೆ. So it is called the marginal distribution. Okay. Now they have said find the marginal. So marginal distribution of x ಹೆಂಗ್ ಕಂಡುಹಿಡಿಯೋದು ಗೊತ್ತಾಯ್ತು. Marginal distribution of y ಹೆಂಗ್ ಹೇಳಿ ನೀವೇ you will probably guess. Y can take values 3, 4, 5. So you find probability y equal to 3. write it here. Y equal to 3 andre x equal to 2, y equal to 3. That case can be there, or x equal to 5, y equal to 3. In last way is x equal to 7, y equal to 3. There are these three ways. Of the 9 ways, 3 ways have y equal to 3. Adina we add it up and we will find that this total 1 by 6 plus 1 by 12 plus 1 by 12 will be 2 by 12 plus 1 by 12 plus 1 by 12. This is 4 by 12. So this is 4 by 12. Adhe tara y equal to 4. Y equal to 4. Ee 9 ಕೇಸಲ್ಲಿ how many cases will have y equal to 4? So the cases are x equal to 2, y equal to 4, x equal to 5, y equal to 4, x equal to 7, y equal to 4. ಈ ಮಧ್ಯದ 3 ಕೇಸ್. So ಇದನ್ನ ನಾವು ಕೂಡಿದ್ರೆ 4 by 12 ಬರುತ್ತೆ. That is probability y is equal to 4. ಅದೇ ತರ ವಿಡಿಯೋ ಪಾಸ್ ಮಾಡಿ find what is the probability y equal to 5. So you will sum these three and find that it is 4 by 12. So this is the marginal distribution of y. Don't leave it in the margin. Make a new table and write it like this. Marginal distribution of y is like this. Y can take values 3, 4, 5 with what probabilities? You can write it neatly as a in probabilities in the decimal form. Because if you leave it like this also, it is perfectly correct. So this is the marginal distribution of x and marginal distribution of y. So first part of the problem we have solved. Find the marginal distributions. Next part, find the covariance between the random variables x and y. So covariance we have to find. This is also very easy. There is a formula. Adukke substitute madodashte ಏನೂ So let us see what this formula is. This formula is the following. Expectation xy is covariance of x and y, x comma y is summation over all the cell values pij xi into yj. If you do a problem, you will immediately see that it's quite simple. Into expectation x, expectation y. Expectation x ಏನು pi xi. ಈ pi's ಎಲ್ಲಿ ತಗೊಳ್ಳೋದು marginal of x ಇಂದ. ಇಲ್ಲಿ ಬರ್ದಿದೆ ನೋಡಿ marginal of x ಇಂದ. Expectation y ಏನು summation of pi by I. ಈ pi's ಎಲ್ಲಿ ತಗೊಳ್ಳೋದು marginal of y ಇಂದ. So let us do this problem. Expectation of x. So pi into xi. So ಇಲ್ಲಿ go to the xi, pi into xi. This is value, this 2, this is better, 2 into 0.5 plus 5 into 0.25, that is same as 1 by 4, plus 7 into 0.25. These three terms you have to add. X value into its probability plus next x value into its probability plus next x value into its probability. Ad madidre expectation x barutte. So just do it with paper and pen and check the answer. Similarly, expectation y in first value of y, which y can take, into probability of that value plus next value y can take into probability of that value. Next, 5 y equal to 5, last value which it can take into probability of that value. If you add this up, you will get expectation of y. So do it and check. Expectation of x came to 4. Expectation of y also came to 4. Okay. So this is expectation of x, expectation of y. Okay. Then pij xi yj. How to do that? Go to the original question table, go to that. Then what do? You just erase all these off. You can So how do you find, what do you do there? This is, go to the first cell. So 2 into 3 into 1 by 6. That's the first value. Like that, these 9 terms you have to sum. Next one will be what? 2, this one. So 2 into 4 into 1 by 6. Next term, 2 into 5 into 1 by 6. Like that, for each cell, the 9 values you will get. Those values you add up. That is Pi summation, double summation, Pij, Xi, Yj. This is also known as expectation of X into Y. Expectation of product of x1 minus expectation x, expectation y. Don't need to remember. What you need to remember is this. It's Pij, Xi, Yj. 9 terms ಮಾಡೋದು. ಅದರಿಂದ minus expectation x into expectation y. This if you do, you get covariance xy. For this particular problem, covariance is 0. Right? So first problem, calculating marginals and then calculating the covariance of random variables x and y. You know how to do. This was a quite simple problem, you'll agree. Let us do one more. The joint probability distribution of the discrete random variable x and y is given below. Determine the marginal distribution. Are x and y statistically independent? So determine the marginal distribution. Let us do it. Then next question they have asked, are x and y statistically independent? That is new thing. We will do it soon. So first let us do the marginal distribution. So first node x can take what values? In node x can take values 1, 3, 6. With what probabilities? You write it here in the margin. What is the probability x equal to 1? Yes, you guessed it right. These three values you have to add up and write it here. 1 by 9 plus 1 by 6 plus 1 by 18. Convert everything to by 18 and do it. 2 by 18 plus 3 by 18 plus 1 by 18. 2 plus 3 plus 1. 6 by 18 ಆಗುತ್ತೆ. 6 by 18. Like that, probability x equal to 3, you add up these and write it. So if you do that, you will get the marginal distribution of x. Pause the video, do it yourself. This is the marginal distribution of x. We had already done that 6 by 18, which is 1 by 3. Next values, ಇದೆಲ್ಲ add ಮಾಡಿದ್ರೆ ಇಲ್ಲಿ ಬರೆಯೋದು. Next ಇದೆಲ್ಲ add ಮಾಡಿದ್ರೆ ಇಲ್ಲಿ ಬರೆಯೋದು. So x takes value 1 with this probability. X takes value 3 with this probability. Whatever we have added and written here, x takes value 6 with this probability. This we write as a table. Marginal distribution of x. Please check ಈ ಮಾರ್ಜಿನಲ್ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ಎಲ್ಲ ಪಿ ಎಕ್ಸ್ ಎಲ್ಲ ಕೂಡಿದ್ರೆ 1 ಬರಲೇಬೇಕು. 1 ಬರಲಿಲ್ಲ ಅಂದ್ರೆ ಏನು ತಪ್ಪು ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಎರರ್ ಆಗಿದೆ ಅಂತ ಅರ್ಥ. ಸೊ ಪ್ಲೀಸ್ ಚೆಕ್ ದಟ್. ಮಾರ್ಜಿನಲ್ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ಸಮ್ ಮಾಡಿದ್ರೆ 1 ಬರಲೇಬೇಕು. Now how to find marginal distribution of y? So y can take values in 1, 3 and 6. 1, 3, 6. Probability y equal to 1 in ಕಂಡುಹಿಡಿಯೋದು. This cell plus this cell plus this cell. These three cells values add ಮಾಡಿ 6 by 18 ಬರುತ್ತೆ. ಹಂಗೆ y equal to 3, how do you get? You add this cell, this cell, this cell, add these values 6 by 12 ಬರುತ್ತೆ. y equal to 6 ಹೆಂಗೆ ಬರುತ್ತೆ? ಈ 3 cell add ಮಾಡಿದ್ರೆ ಈ value ಬರುತ್ತೆ. So this is the marginal distribution of y. But you must write it in a different table. Y can take values 1, 3, 6 with probabilities. These are the probabilities. So now, okay, they have, so yeah, they have said this is find the marginal distributions and are they statistically independent? Statistically independent ಆಗಬೇಕಾದ್ರೆ ಏನಾಗಬೇಕು? The product of the marginals is equal to the cell value. Avaga, it will be independent. So how to check that? Marginals, I'll just make it little small so that we can get everything on the same page. Zoom out. ಇಲ್ಲಿ ನೋಡಿ cell values marginal, this is y equal to x equal to 1, y equal to 1. Probability is 1 by 9. P x equal to 1, probability is 1 by 3. Y equal to 1, probability is 1 by 3. Marginal sum. Other product is 1 by 3 into 1 by 3. That is same as 1 by 9. So it is in this case correct. Next, let us check the next case. X equal to 1, y equal to 3. X equal to 1, y equal to 3. What if I take the product 1 by 3 into 1 by 2, that is 1 by 6. So in this case also correct. Like that, all 9 cells you should check. ಪ್ರತಿ ಒಂದರಲ್ಲೂ ಆ ಥರ ಮಾರ್ಜಿನಲ್ಸ್ ಪ್ರಾಡಕ್ಟ್ ಮಾಡಿದ್ರೆ ಸೆಲ್ ವ್ಯಾಲ್ಯೂ ಬರುತ್ತೆ ಅಂತ ಅಂದ್ರೆ ಎಸ್ ಇಟ್ ಇಸ್ ಸ್ಟ್ಯಾಟಿಸ್ಟಿಕ್ಲಿ ಇಂಡಿಪೆಂಡೆಂಟ್. ಈ 9 values or in all the cell values, even if there is one cell which it is not equal, the product of the marginals is not equal to the cell value, then x and y are not independent. So let us do one more problem. Just to recap this, in this lecture, this is what we will cover. If you want to see more practice of these concepts only, you can see some one more problem. Otherwise, you can go ahead and we will cover what is hypothesis testing in the end, continuing this lecture. So one more problem of this kind. What is this? Find the covariance between x and y in table ಕೊಟ್ಟಿದ್ದಾರೆ. Are x and y statistically independent? So you can just go through, these are the values, x equal to 1, y equal to 2, like that. So how do you find whether they are statistically independent? First, of course, covariance. So whether they ask in the exam, covariance ಕಂಡುಹಿಡಿಯಕ್ಕೆ ಹೇಳಿದ್ರು ಮಾರ್ಜಿನಲ್ಸ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು, ಮಾರ್ಜಿನಲ್ಸ್ ಟೇಬಲ್ಸ್ ಬರಿಬೇಕು. ಸುಮ್ಮನೆ ಫೈಂಡ್ ಇಫ್ ಇಟ್ ಸ್ಟ್ಯಾಟಿಸ್ಟಿಕ್ಲಿ ಇಂಡಿಪೆಂಡೆಂಟ್ ಅಂತ ಕೇಳಿದ್ರು ಮಾರ್ಜಿನಲ್ಸ್ ಬರಿಬೇಕು ಟೇಬಲ್. ಸೊ ಯು ಹ್ಯಾವ್ ಟು ಫೈಂಡ್ ದ ಮಾರ್ಜಿನಲ್ಸ್. ಸೊ ಯು ಕ್ಯಾನ್ ಪಾಸ್ ಅಂಡ್ ಫೈಂಡ್ ದ ಮಾರ್ಜಿನಲ್ಸ್. ನೋಡಿ ಹಿಂಗ್ ಬರುತ್ತೆ. ದೀಸ್ ಆರ್ ದ marginal for y. Y takes value 1, 2, 3. These are this is the marginal distribution of y. This sum, marginal distribution of x is this sum. So this is the marginals x and y. Now expectation of x, how do you do? 1 into this 0.36 plus 2 into 0.32. It is here. It comes to 1.96. Next, marginal of y is 1 into 0.04. So that will come to 1.90. Like expectation of xy, take the product x into y into pxy. This pxy ಎಲ್ಲಿಂದ ಬರುತ್ತೆ? ಕೊಟ್ಟಿರೋ ಟೇಬಲ್ ಸೆಲ್ಸ್ ಇಂದ. ಸೊ 1 into 1 into 0.32. ನೋಡಿ ಇಲ್ಲಿ 1 into 0.32 plus 1 into 2 into 0.03. ಆ ಥರ ಆಲ್ 9 ಟರ್ಮ್ಸ್ ಬರ್ಕೊಳ್ಳೋದು. ಬರ್ಕೊಂಡು ಎಕ್ಸ್ಪೆಕ್ಟೇಷನ್ ಎಕ್ಸ್ ವೈ ಬರುತ್ತೆ. ಸೊ covariance xy is expectation of xy minus expectation x into expectation y. So expectation of x into y is 4.22. I think this values in the second place of decimal slightly wrong. In last class, we saw 28 or bantu. Anyway, minor error. Please correct it. So expectation of xy is this value minus product of these two, expectation x into expectation y. ಅದನ್ನ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ ಕೋವೇರಿಯನ್ಸ್ ಇದು ಬರುತ್ತೆ. To check statistical independence, it is independent if all 9 are p of x comma y is product of the marginals. So let us try for p11. Given in the table is 0.32. Marginal p x equal to y is 0.36. Marginal p y equal to 1 is 0.4. Marginal to p x equal to 1 is here. So this product, is it equal to what is given in the cell? So if you do it, what is given in the cell value is 0.32. You can check here. 0.32 px. P of x equal to 1 comma y equal to 1 is 0.32. P of x equal to 1 is 0.36. P of y equal to 1 is 0.40. Average product ತಗೊಂಡ್ರೆ ಹಿಂಗ್ ಬರ್ತಾ ಇದೆ 1.96 into 1.9. You got this value. So subtract these two. Okay, sorry. Where do probabilities x equal to 1 is 0.36. Y equal to 1 is 0.40. Where the multiply mod value is not equal to the one given in the cell. So it is not independent. Suppose P11 idagidre alli yes it is independent annakagala. Next cell check ಮಾಡಬೇಕು. ಆತರ ಪ್ರತಿ ಒಂದು ಸೆಲ್ಗೂ ಅದು ಈಕ್ವಲ್ ಆದ್ರೆ ಮಾತ್ರ ಇಂಡಿಪೆಂಡೆಂಟ್ ಅನ್ಸ್ಕೊಳ್ಳುತ್ತೆ. ಯಾವ್ದಾರೋ ಒಂದು ಸೆಲ್ ಅಲ್ಲೂ ಅದು product of the marginal values is not equal to the given cell value. One cell allu ಆ condition satisfy ಆಗಿಲ್ಲ ಅಂದ್ರೆ it is not independent. Okay. Now this we have covered these joint distribution functions. Next we will cover is hypothesis testing. So hypothesis testing, in this lecture, in the remaining part, I will do the theory part of sampling and hypothesis testing. Actually, problems 1 will be in the next lecture. This hypothesis testing comes as theory question, 6 marks or barutte. They ask these 5-6 different definitions irutte. Adral ಮೂರ್ ಡೆಫಿನಿಷನ್ ಕೇಳ್ತಾರೆ 2 marks. ಸೊ ಅದು ಇಟ್ಸ್ ಈ 6 ಕಲ್ತ್ಕೊಂಡ್ರೆ ಅದಕ್ಕೆ ಶ್ಯೂರ್ ಕ್ವೆಶ್ಚನ್. ದಿಸ್ ಕಮ್ಸ್ ಆರ್ ಇದು ಫೈಂಡ್ ದ ಈ ಜಾಯಿಂಟ್ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ಈಗ ತಾನೇ ಮಾಡಿದ್ವಲ್ಲ ಅದು. ಕ್ವೆಶ್ಚನ್ ನಂಬರ್ 9 ಅಲ್ಲಿ ಒಂದು, ಕ್ವೆಶ್ಚನ್ ನಂಬರ್ 10 ಅಲ್ಲಿ ಒಂದು ಸಾಮಾನ್ಯ ಹಂಗಿರುತ್ತೆ. ಸೊ if you are lucky you may get both in the same question, but unlikely. Okay, so quick age in yaud beku, they will ask. Main thing is what is very important is types of errors. But before that, solpa just get quickly we will just see what is this testing of hypothesis andre enu quick ag nodona. Before we start with hypothesis testing, one sati population eno, sample eno. Suppose you have a factory which you are manufacturing bulbs. Whole factory nalli go down nalli iddid ella idre, that is your population of the bulbs. All possible units is the population. Now you want to test how good the bulbs are. You only 1,00,000 bulbs idre, there is no time or energy to check each and every bulb. So, but you want to estimate, say you want to estimate lifetime of the bulbs. ಎಷ್ಟು ಗಂಟೆ ಕಾಲ bulb ಉರಿಯುತ್ತೆ ಅಂತ. You can't check 1 lakh or 10 lakh bulbs. You cannot check each and every one. So what will you do? You will pick out a sample. Chick what maybe 10 bulbs, maximum 20 bulbs, like that you will pick. How will you pick? You will not go to one consignment, one shelf in the one good in the pick madala, one big kadeinda, one da kadeinda, like that. You will pick from all over the go down, different days manufacture madiddu atara. You will come and pick 10 and then check it. Check how long these bulbs last. So you can, using that, you can estimate for the entire population. So concept, what is population? The entire, all the readings is population. Sample is subset of the, from the population if you take subset. Now what is parameter? Parameter is constants of the population, which we cannot check, but it's there. Mean of the entire go down. Mean of the entire go down and the mean life, average lifespan of the bulbs of all. If we could add up all the, test each and every bulb, add up everything and find the mean, that will be the population mean, denoted by mu. Standard deviation is a measure of how much ಏರುಪೇರು, mean ಹತ್ರನೇ ಎಲ್ಲ. If mean is say 800 hours, ಎಲ್ಲ ಹೆಚ್ಚು ಕಮ್ಮಿ 801, 802, 799 ಆ ತರ ಅಕ್ಕಪಕ್ಕ ಇದ್ಯಾ ಇಲ್ವಾ ಅಂತ. ಅಕ್ಕಪಕ್ಕ ಆವ್ರೇಜ್ ಅರೌಂಡ್ ಇಟ್ ಹೆಚ್ಚು ಕಮ್ಮಿ ಎಲ್ಲ ಸೇಮ್ ಆಗಿದೆ ರೀಡಿಂಗ್ಸ್ ಅಂದ್ರೆ ಈ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಡಿವಿಯೇಷನ್ ಚಿಕ್ಕ ವ್ಯಾಲ್ಯೂ ಇರುತ್ತೆ. 800 is mean, but some bulbs go on to 900 and some bulbs go out at 700 only. Then standard deviation is more. Okay, just need this concept. For this exam, we don't need the details. This is what standard deviation means. So mu and sigma of the population is population mean and standard deviation denoted by sigma. ಈಗ ಸ್ಯಾಂಪಲ್ದು ಮೀನ್ ಇರುತ್ತೆ. ನಾವು 10 ಅಷ್ಟೇ, 10 ಬಲ್ಬ್ ತಗೊಂಡು ಅದರ 10 ರೀಡಿಂಗ್ ಎಷ್ಟು ಲೈಫ್ ಆಫ್ ಈಚ್ ಆಫ್ ದೋಸ್ 10 ಬಲ್ಬ್ಸ್ ನೋಡಿ ಅದರ ಆವ್ರೇಜ್ ತಗೊಂಡ್ರೆ ದಟ್ ಇಸ್ ಸ್ಯಾಂಪಲ್ ಮೀನ್. ಅಂಡ್ ಆ 10 ಸ್ಯಾಂಪಲ್ದು ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಡಿವಿಯೇಷನ್ ಫಾರ್ಮುಲಾ ಇರುತ್ತೆ, ಅದು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದ್ರೆ ದಟ್ ಇಸ್ ಕಾಲ್ಡ್ ಸ್ಯಾಂಪಲ್ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಡಿವಿಯೇಷನ್. So population parameters and these are sample parameter statistic. They are called statistic. When we take the these mean and standard deviation etc. of the sample only, it is called statistic. Okay, these notes are available to you. You can check from there also. Now, what is a hypothesis? Hypothesis is a theory. In this context, it means a statement about the population which we want to test, denoted by H naught. So mu equal to 5 andre mean, the population has mean life 5 anta. Now this is an example of a hypothesis. Alternate hypothesis is, we can say, okay, mean H1, it is denoted by mu, the mean life of this is not equal to 5. That is called the alternative hypothesis. Andre hypothesis ಏನು ಅದನ್ನ ನಾವು ಇಲ್ಲ, ಅದು ಸುಳ್ಳು, that is false ಅನ್ನಕ್ಕೆ this is the alternative hypothesis. Okay, now next important thing which they ask is type 1 and type 2 errors. Okay, when you have a hypothesis, suppose if we go back to our example of 800 hours is the average life of bulbs anta the factory manufacturer tells. Now say you are coming, you are from a different company, say you are from a residential hotel lodge, you want to buy a big lot of bulbs. Now the bulb owner tells that mean life of the bulbs is 800 hours. You pick, you are a quality control person, you pick 10 bulbs. Otherly, you find that the average life came to 770, 30 hours less than what they told. Now you think, see, there are two decisions you can take. You can say, okay, maybe little sampling error, some will have less, some will have more, it is okay. Your what you're saying 800 is correct. I will take it. You can take it, or you can say no. What you are telling actually lies. It is not so high. I will not take it. I will reject it. I don't want. So now it was your decision correct or not? It will depend. Suppose hypothesis is true, Andre, actually lifespan of the bulb is actually 800, and though it came little less, you accepted it. If hypothesis is true and you accept, it's a correct decision. Now take the another case. H0 is false. Actually, it is not 800. The company is telling lies. And you reject H0. You say, no, I will not. I don't agree to you. Then also your decision is correct. So these two cases, decision is correct. If the hypothesis is true and you accept that it is true, correct decision. Suppose hypothesis is false and you reject it, that is also correct decision. Now let us see the errors. Now say hypothesis is false. Actually, our company 800 anyway, but you say, okay, we'll take it, maybe some little error. It's okay. If you accept it, then you have made an error. This is called type 2 error. When actually it is false, but you have accepted. Type 1 error, hypothesis is true. Actually, Papa out correct age ಹೇಳ್ತಿದ್ರು 800 ಇದೆ, but in our sample ಒಂಚೂರು ಕಮ್ಮಿ ಆಗುತ್ತೆ. But ನೀವು ಕೋಪ ಮಾಡ್ಬಿಟ್ಟು ಬೇಡ ಅಂದ್ಬಿಟ್ರೆ, it is you have done type 1 error. Type 1 error means though it is true, you have rejected it. So this is type 1 error, type 2 error. This table you will need to know, they ask. So this is the types of errors. Okay. Confidence interval. This is a concept which needs some time. Confidence interval is, see, you have the sample, what you have calculated. Now, we told our sample mean came to 770. Now, what is the chance if actually 800, the population mean is 800, but sample can be little less, sample mean can be little less, 770. With what confidence can we say that this is not from the population? That is called confidence interval. It takes little more geometry. You have to see that curve and tell. Right now, since you are preparing for the exam, you can skip it. You just learn these definitions. It is enough. More detailed exam explanation, please come to me in person. I will definitely explain it to you. Okay. Now, what is a test statistic? Now, in our syllabus, we have 3 tests. One is Z test, one is T test, one is chi-square goodness of fit test. These are the test statistics. These notes will be with you. So, test statistic for Z, if they will be x bar, that is what you calculate. Mu will, if mu is given, that is mu is your population parameter by sigma by n. This will be given to you. These are the 3. Just check in the notes. These E3 formula beku. E3 formula ಒಳಗಾಗಿ ನಮ್ದೆಲ್ಲ problems. We did module 5 problems, so you can note it down. So this, we will stop this lecture here. How to apply these 3 formula to solve the problems, we will do in next class. So what are these tests for? Concept ಏನು? We will check using, we will do some magic here, and we will decide whether to accept the hypothesis or reject the hypothesis. This value we will compare with, they have given in the problem only one value ಕೊಟ್ಟಿದ್ದಾರೆ. ಈ ಫಾರ್ಮುಲಾನಲ್ಲಿ ನಾವು ಪ್ರಾಬ್ಲಮ್ ಓದಿ ಈ ಫಾರ್ಮುಲಾನಲ್ಲಿ ಇದೆಲ್ಲ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ ಒಂದು ವ್ಯಾಲ್ಯೂ ಕಂಡುಹಿಡಿಯೋದು. We will check if ನಾವು ಕಂಡುಹಿಡಿದಿರೋ ವ್ಯಾಲ್ಯೂ ಅವ್ರು ಕೊಟ್ಟಿದ್ದ ವ್ಯಾಲ್ಯೂಗಿಂತ ಜಾಸ್ತಿ ಇದ್ರೆ we reject the hypothesis. If ಅದ್ರ ಒಳಗಾಗಿದ್ರೆ we accept the hypothesis. So that is the theory. Actual problems we will do in the next lecture. Okay, thank you. See you again for the next lecture.